Hi, my name is Muhammad Aiman bin Samsuri, and I am going to explain to you about my assignment, task 1. The topic is about Lagrange polynomials. So, the first question is, from the given link, fill up table 1 with related values, assuming 1 month equivalent to 30 days only. So, this is the data that I have obtained when I open the link given in the question. So, question B, use the quadratic Lagrange interpolating polynomial for the given values in table 1 in A to approximate y equal to fx for 5 June 2025 and 11 March 2026. So for the first question, 5 June 2025, which is 4 days after x1, 31 days. This is x1. So x equal to 31 plus 4 equal to 35 days. Then you must arrange the table from the data in order. Then you must write the data for L0 until L4 by using the Lagrange equation. Then when you get the answer for L0 until L4, you can substitute the y values by using these y values. Then you will get the answer for P4. For question 2, 11 March 2026, you just do the same working step as question 1, but it is for question 2, 11 March 2026, it is 10 days after x10, which is 301 days. So x equal to 301 plus 10 equals to 311 days. Then you just arrange the data from the table in order, then find L1 until L11, and lastly you can substitute the y values by using these y values, and then you will get the answer for P4. Then lastly, question C, make conclusions on the accuracy of the approximations for B1 and B2 in comparison to the exact data given in the website. So firstly, we must find the absolute error. The formula is actual price minus estimate price over actual price times with 100. So the actual price for June 5 equals to 14.20 and March 11 equal to 14.24. So this is the answer from the P4 that you calculate earlier. Just substitute the answer and you will get the last answer. So that's all. Hi, my name is Muhammad Aiman bin Samsuri. Today I'm going to explain to you about my assignment, task 2. The topic is about Newton's finite divided difference. So the question is, extract information from the graph monthly basis, then construct the Newton's finite divided difference table up to the 5th order for the both companies. This is the data that I have obtained from the link given in the question. So firstly, you must do a table up to 5th order, 5th DD. So the first DD, how you get the answer? 0.5 you minus with 4.20 over with 2 minus 1, and then you will get the answer 3.7. So the second DD, negative 2.1 minus 3.7 over 3 minus 1. For the third DD, 1.45 or 1.45 minus 0.8 over 4 minus 1, and then we get the answer. For the fourth DD, 0.14667 minus 0.21667 over 5 minus 1, and then you will got the answer. And for the last order, the fifth DD, negative 0.34125 minus negative 0.1 negative 0.0175 over with 6 minus 1, and then you will got the answer. Just do the same working step for the both companies. So the next question is calculate the Newton's forward FDD polynomial Pnx that passes through all the given points at 0 equal to 1 for the Malayan Banking Berhad Company. So when you have done with the table from the question 1, it is easier for you to highlight the data that you want to use for the second question. So the second question asks you to add 0 equal to 1. So this is x0, this is x1, and so on. So after you highlight the data that you needed, you just put the data in the equation like this, and you will get the answer. For the third question, calculate the Newton's backward FDD polynomial Pnx that passes through all the given points at 0 equal to 11 for the CIMB group holdings. So for the CIMB group holdings, the question asks you to do the backward. So the question asks you to x0 equal to 11. So 11, this is 11, and this is also x0. This is the starting, and x1, x2, and so on. So you highlight this as x0, and then you just do the same working step as the question 2. So lastly, question B, refer to the same data. Use the method of discrete least square polynomial of degree 2 to fit a parabola for each company. Degree 2 means it is quadratic. So for Malayan Banking Berhad, you can use your calculator for this question, and you will get the answer for Malayan Banking Berhad and CIMB Group Holdings Berhad.
Assalamualaikum and hello everyone. My name is Izrul Shah. Today I am presenting my solution for a task 3, which focus on discrete linear least square approximation. They are given a set of 5 data points in the table 2, and our goal is to model them using this nonlinear power equation. Because the equation is nonlinear, our very first step is to transform it into a linear format. Y is equal to a0 plus a1x. So the given function is y is equal to a plus x power 2 over b x power 2 respect to the power 1 over 2. We have to eliminate the square root from the right hand side. To eliminate the square root power, we move it to the left hand side. It become a power of 2. After that, we separate the equation to get a a0 plus a1x. When we see x over b x power 2, we can also eliminate it. Finally, we need to isolate the x that is under a over b s over 2 to make it equation for x. In the second step, with our transformation ruler set, I construct this calculation table for each given x and y value. I calculate x equal to 1 over x power 2 and y is equal to y power 2 along with the product and square. Summing up, this column gives us the asymptotic component need for our normal equation metric. As you can see below the table, substituting our n is equal to 5 data point and our summation value into the standard metric form. with the system. A 2 by 2 matrix multiplied by our unknown coefficient A0 and A1 equal to our transform data vector. The last step in question A, solving the system of linear equation give us the value for our linear parameter. By mapping this back to our original constant, we find that B, which is 1 over A0, equal exactly 2.0000. Using that, we find our constant A is approximately 0.9999. Substituting this constant back into our original formula give us our final, highly accurate approximation model shown right here at the bottom. Finally, for part B, we are asked to approximate the value of y when x is equal to 3.35. By plugging 3.35 directly into our newly determined model and computing the square root of the expression, we get a final estimate value of 0.7379. This completes the least square approximation process successfully. Thank you for your time.
Assalamualaikum. My name is Muhammad Danish Irfan bin Rosli. Now, I go to assignment MAT575, and then my task is task 4. First, we read the equation is a degree 2 and function is fx cos x plus 3x square. First question is state the general and legend for the degree 2. Then this is the equation. P naught equal to 1. Okay, next, if the equation is linear transform, identify. So this is if interval -1 1, no transformation needed. So find the number 3. Interval is -1 1. So -1 1, we use A0 P naught A1 plus A1 P1 x plus A2 P2 x. Then AK, this is the formula. So find the A0, find the A1, we get 0, and find A2. And then combine all, then we get the answer for the fx. And then second question is interval 0 and 2. First, we need to transform x to t. Then we must use a matrix. Then we get A minus A equal to 1 and B equal to 1. For the t equal to x minus 1 and x equal to 1 plus t. So same step, we find the A0, A1 and A2, and then combine all. For the PT, no fx, PT. And then after all, since t equal to x minus 1, so px, sorry, so for the px, same all. And then x minus 1 square, then you get there, then dapat ni. And then after all, and then we get the answer. Then thank you.